My dear students, now we are going to look at lecture number 33, where we are going to design Martin synchronous down counter. Synchronous down counter will count down from 9 to 0. Okay, so 9 to 0, 9 to 0, 9 to 0. This is what exactly the circuit that we would like to design. The objective for us is to design such a counter. Upon application of the clock, every time it will decrement it by 1. If it is 9, 9 becomes 8, 8 becomes 7, 7 becomes 6, so on and so forth up to 0, then followed by 9. So this is what exactly known as mod 10 down counter. For this counter, what I am trying to do is, I am trying to look at the steps required. First, we will try to find how many flip-flops required. 2 power n should be greater than or equals to capital N, where n is equals to 10. Small n, 2 power n should be greater than or equals to 10. Small n is equals to, let's say, 3. 2 power 3 greater than or equals to 10. Invalid. Let's say n is equals to 4. When n is equals to 4, what is going to happen? When n is equals to 4, 2 power 4. 2 power 4 greater than or equals to 10. So 2 power 4 is 16 greater than or equals to 10. For n is equals to 4, it is true, valid. So we need number of flip-flops is equals to 4. N is equals to 4. Let us use T flip-flops. Okay, we would like to use the T flip-flop. Then we need to draw the state diagram. What exactly, how exactly it look like? It will go from 0 to, is it go from 0 to, what exactly, if it is in 0, it will go to, next state is 9. 9 becomes 8, 8 becomes 7, 7 becomes 6, 6 becomes 5, 5 becomes 4, 4 becomes 3, 3 becomes 2, 2 becomes 1, 1 becomes 0. We will continue it. This we will show it clearly. Then we need to develop excitation table for the counter. Then we will get the expressions for the inputs. So now what I try to do is, we have looked at step 1 and step 2. Now I need to look at step 3. What is step 3 is, draw state diagram. So how to draw the state diagram? We will look at it. So state diagram is very simple, wherein we will be moving from one state to other state, but it's a countdown sequence. Okay, so we will draw this countdown sequence. So we will start with the 0. Next state to 0, 0 is 0, 0, 0, 0. Next state to 0 is 9. Next state to 9 is 8. Next state to 8 is 7. Next state to 7 is 6. 0, 1, 1, 0. 0, 1, 0, 1. 0, 1, 0, 0. Okay. Then 4. Then what we need to do is 4. What exactly next is 0. Then 1, 0, 0 becomes 3, 0, 1, 1. 0, 1, 0. Okay. 0, 1, 0, 0, 0, 1. Okay. Then 0, 0, 0. So 0, 0 to 1 to 9. 1 to 0, of course, 0 to 9, 9 to 8, 8 to 7, 7 to 6, 6 to 5, 5 to 4, 4 to 3, 3 to 2, 2 to 1, 1 to 0. This is known as state diagram. State diagram. Once we in the state diagram, it's very clear that we are moving from 0 to 1, 1 to, 0 to 1 to 0, 0 to 9, because it's a down counter, 9 to 8, 8 to 7, so not so. So once we know this, then we try to see. So what I try to do is, the initially we call it as a present state, next state. Present state, let's say QA, QB, QC and QD. Next stage is QA plus 1, QB plus 1, QC plus 1, QD plus 1. From the state diagram, when input is 0, 0, 0, 0, okay, the output will be 9, 1 0 0 1. If the present state is 1, okay, present state is 1, next state is 0, present state is 1, next state is present state is 2, next state is 1, present state is 3, next state is 2. See, present state is 3, next state is 2, present state is 4, next state is 3, present state is say 5, next state is 4. Okay, so this is present state. PS stands for present state. Okay, so you are moving from one state to the other state. The state is such that it shows that the counting is going in decrement or down, that is high to low, then 0, then 9. So anything greater than 9, anything greater than 9, for which what exactly the next state? Next state is don't care. It is don't care for all the cases, that is 10, 11, 12, 13, 14 and 15. Next state is all don't cares. As next state is don't cares, flip-flop inputs also don't cares. So flip-flop inputs also written as don't cares. Now we will be looking at getting the appropriate flip-flop inputs, okay, in order to make the design. So what we try to do is, we try to look at this 0 compare with 1. QA and QA plus 1. From this state to this state it has to go. So what it should be the value of TA, what should be the value of TB, TC and TD. Okay. So TA is LSB, TD is MSB of course. So when compare 0 with 1, so 1. So now you have to compare this with this with this. Okay, this 1 with this 0, this 0 with this 1. So every time 1 0 or 0 1, 1 0 or 0 1, 1 0 or 0 1, 1 0 or 0 1. Okay. So what is the meaning of that is all my TA values are 1s. How I am getting this? From the excitation table of T flip flop. What is the excitation table for T flip flop? Very much known. Qn, Qn plus 1 and TA. 0 0 0, 0 1 1 0 1 1, 1 1 0. If it is same, TA should be 0. If it is different, TA should be 1. So that can be, if this is not exactly TA, of course we can say that it is T. Okay. So T stands for T flip flop. That you can apply it for A, B, C, D in our case for all flip flops. Now we can compare, say here, this is TB has to be compared with QB has to be compared with QB plus 1. We need to compare QC with QC plus 1. We need to compare QD with QD plus 1. Okay. So once you make the comparisons, then you will come to know, okay, all the, okay, flip flop. So once that is being done, then what we try to do is, we are going to get expressions for TA, TB, TC, TD in terms of QA, QB, QC, QD. So compare B, this is 0, this is 0, this is also 0, this is also 0. So 0, 0, 0, 0. Next 1, 1, whereas this is 0, whereas this is 1. So when 1, 0, it is 1. Next 1, this is 1 and this is also 1. So it is 0. Similarly, 0, 1, 0, 1, 1, 0, 0, 0, 1, 0. What is 1, 0? 1. Right? Next 1, 1, 0, 0, 0, QB plus 1. 1. What is 0, 1? Is 1. Next 0, this is 0 and this is 0. Will give you 0. Okay. So for QA, this was 1, this was 0. So it is also 1. So similarly for TC, if at all you look at QC and QC plus 1. QC, first 4 zeros. First four zeros. So TC is 0, 0, 0. First four. This is 1, this is 0. So it is 1. Next, see the ones. How many ones I have? 4 ones I have. How many ones I have in QC plus 1? This is 0, this is 1 done. So here I have 4 ones, but up to here only it is same. So it means 3 ones common. These 3 ones and these 3 ones are common. So for those values, for 3 zeros I will get it. For this one it is 0. So what I try to do is this 1 and this 0. So output is 1. Of course, the TC input is 1. Then what exactly the next? Next I need to compare this 0 with this 0. So for 0, 0 it is 0. So next you compare QD and QD plus 1. So QD, if at all you look at how many zeros? 4 zeros plus 4 zeros. How many zeros? So first this first one is 0 and 1. So it is 1. Then followed by 7 zeros, and here also we have 3 zeros, then 4 zeros of course. So 7 zeros possible, 7 zeros possible, 3 plus 3 plus 2, 5 plus 2, 7. 1 7 zeros is done. If I compare this one with this 0, so it is 1. Okay, then what I need to do, this one should be compared with this one, so it is 0. Anything more? Nothing, right? So what I got here is it is 1. Now what I can do is I can do this diagram, and I can get the values for expression for TA, expression for TB, expression for TC, expression for TD. TA is function of QA, QD, QB, QC and QA. Okay, similarly TB, TC and TD. What I mean to say is the TA, TB, TC, TD, these 4 are functions of this 4. Okay. So what exactly I try to do is I will enter the values. This is the table for a TA. I will enter values of TA. What are the values of TA from the table? It is always 1 and don't cares. Don't cares are there for 10, 11, 12, 13. So 10, 11, 12, 13, 14 and 15 are don't cares. Rest all are ones from the table. So when all are ones, what I can do is I can combine like this. Then what I am going to get is expression for TA is 1. Next we will look at expression for TB. This is for expression for TB. So if you look into the diagram, what is TB is? TB is 1 for 2. So this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, 6, 7, 8, 9. Right? So from 10 onwards it is don't cares. 10, 11, 12, 13, 14, 15 are don't cares. Up to 9 you have the values. So what I mean to say is TB is 1 for 2, 1 for 4, 1 for 6, 1 for 8. 2, 4, 6, 8. So I can say TB is sigma m 2, 4, 6, 8 plus don't care terms of 10, 11, 12, 13, 14, 15. So what if I take the don't cares, this is 10, 11, 12, 13, 14, 15. Next it is 1 for 2, this is 2, the 1 for 4, 1 for 6, okay, 1 for 8. So what I need to do is just I can combine all of them like this. Then I can combine this 2 with this 2. I can combine this 2 with this 2. Right? So with this what I am going to get? I am going to get the expression. So the expression for TB is, this is what exactly? This is exactly QA, QB, QC, QD and QC in our case. Okay. So the expression will be, what exactly it is? The expression will be QA, QB, QA bar. Okay. This is one expression. When I compare these two, What is this? That is exactly I am going to get is QA bar. QA bar is common. In this, it is QD. So QD QA bar plus, once again this is QA bar, but what is common over here is QC. So QC QA bar. This is expression for TB. Okay. So when you look at the next K map this is for QA, QB, QC and QD. Right. Now what is this is for TC. Now what is TC? TC is sigma m. For which values it is 1? For which values of it is 1? Okay. It is 1 for, if you look at the table, it is 1 for 4, 1 for 8, 1 for 4, 1 for 8. So you put in place of 1, it is 1 for 4 and 8. Don't care, don't care, don't care, don't care, don't care, don't care. So I can combine these two and I can combine this two. So the expression for TC turns out to be, okay, QA bar, QB bar, QA bar, QB bar. And what is common in these two is QC. Next, what is common in this is QD. So QD, QEB bar and QA bar. This is expression for TC. Next, what we try to do is we will go for TD. So QA, QB, QC, QD. Okay. So now we know is these are the don't care terms for this table, and it is 1 for what? QD is 1 for, you can check it into here. QD is 1 for 0, 1 for 0. Here I can change the color if you required. So here it is 1 for D and also 1 for 8. So for 0 and 8 it is 1. So for 0 it is 1, for 8 it is 1. So for 0 it is 1 and 8 it is 1. So what I can do is I can combine these two, okay, and also I can combine these two. So if I do that, what I am going to get is, like, this is for table for TD, the expression for TD will be, okay, what I can do is I can write the expression like this. What is that is, when these two are combined, so this is QA bar, QB bar, QA bar, QB bar, and what is common over here is QD plus, it is 1 for 0 and, right. So what I can do is I can write the expression as QA bar, QB bar and QC bar. So QA bar, QB bar and QC bar. Okay. So what I can do is, instead of combining these many times, what I can do is just small correction here. What is that is, so we will make an attempt where this is not required, this is not required. Directly if I combine these two, what exactly the expression that I am going to get? Because we need to combine once, no need of don't care. So that is the case. If that is the case, then what exactly that I am going to get is, here is TD turns out to be, what is exactly that is, it is QC bar, QC bar, QB bar and QA bar. Very simple expression. Okay. No need of going to combine with don't cares and make it complex. Okay, not required. Because we need to combine ones, only two ones are there, we will get one combination. So knowing these expressions, expression for TA, TB, TC and TD, we got to draw the circuit diagram. What is TA I got is always 1. What is TC I got? TC turns out to be is this. Shall I repeat that? QC, QA bar, QB bar, QD, QA bar, QB bar. So QC, 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 QA bar, QB bar plus QD, QA bar, QB bar. What about TD? TD is QA bar, QB bar, QC bar. QA bar, QB bar, QC bar. What is TB? What is TB is QB QA bar, QD QA bar, QC QA bar. Okay. So QA bar, this is QA bar QB, QA bar QC plus QA bar QD. Okay. So this is what exactly QA bar QB, QA bar QC, QA bar QD. This is so from this what I can do? I can draw the circuit diagram. How it look like? So I will be having one flip flop here, then next flip flop over there, then next flip flop, then next flip flop. So one is A, another one is B, another one is C, another one is D. So now what exactly I need to do? I need to have a common clock. Clock is common for all of them. I have a common clock, synchronous counter, which is a down counter. Once the clock is common, what exactly I need to do? For A, I have a QA and QA bar, QB bar, QB available. Input is TB. From this QC is available and QC bar available, QD bar available, QD available. This is TD and this is T flip flop D. So here it is TC. Okay, it is TC, TC. So what is the TC value, TD value, and the TB value and TA value? TA is equal to 1. So this is A, TA, TA is connected to 1. Okay, TB is connected to, as per the expression, where exactly TB connected? TB connected to QA bar, QD, QC bar. So you need 3 AND gates. Okay, take an AND gate, take an AND gate, take an AND gate, QA bar, QB, QA bar, QC, QA bar, QC, QA bar, QD. So all these things what I need to do? I need to give it to OR gate. Okay, we'll get an output. This will correct it. So these are 3 AND gates, then followed by OR gate. Similarly, TC. What is TC? TC is QA bar, QB bar, QC, QA bar, QB bar, QD bar. Okay. So from TC, we will get a TA bar, TC, QA bar, QB bar, TC, QA bar, QC bar, QD. So there is no bar here. For this, there is no bar. Okay. So once again, 3 input AND gates to 1 OR gate, 2 input OR gate, from which we are going to get similarly from this expression. Okay. So we will get this TC. So what for TC, what we need? 3 input AND gates to, okay, one is QA bar, another one is QB bar, another one is QC, QA bar, QB bar, then QD. These two should be connected to an OR gate. Okay, from the OR gate, what we try to do is we are going to apply it to TC. So this we will give it to OR gate, and OR gate output is connected to TC. What about TD? Now if you look at the TD, TD is QA bar, QB bar, QC bar. So QA bar, QB bar, QC bar. These 3 you have to give it to AND gate. So what I try to do is just I will erase this, then I'll show you an AND gate, 3 input AND gate, and connected to here. This is TB. Okay. So one of them, there will be 3 inputs. One will be connected to QC. The other one is connected to QB bar. The another one is connected to QA bar. Okay, here it is connected. Right. So this is how you need to make a connections in a circuit diagram in order to get a 10 bit, mod 10 down counter, or what exactly mean is BCD down counter. So we can call it as mod 10 down counter, or BCD down counter. Okay, done.